And in case you forgot, there was already somebody mentioned something about the extra credit, so if you weren't sure what that meant, 7.5, I made it extra credit. So you don't have to do it if you don't want to. If you do it, cool. I got to remember to change it online to 0 points. So if you do try it, it won't count against you. 7.5, section 7.5 is extra credit. Yeah, the homework that's assigned. It would be if you do it, it's extra credit. If you don't do it, you're fine. Yeah, just like a bonus thing. So last time we did stuff like this. Here we go. Let's try this one. This is nice. I want to show you a couple ways to do this one.
Is that on here?
Which one is this?
What's up?
Is it 7.8?
7.6, number 16. Say what?
Is this from the homework?
It's from the homework section. Is it from the homework I assigned? I don't know.
No.
If it is, then yay. If it isn't, oh. Sometimes I try not to pick the homework because that's what I want you guys to do. Weird things are happening. All right, so who's got a suggestion? There's two kind of main ways to do this specific problem. Who's got a suggestion?
Try to get T on the same side.
Say again?
Try to get T on the same side.
All right, we got kind of like terms going on here, right? So one way to do it is kind of nice, is do what with this here?
Multiply.
Okay, that's the second way to do it. So let's do one at a time. One way to do it is to do like Trenton said, which is to get 4t over here, right? Get the t stuff together, right? That's more like, and the reason we can do that here and not on some of the other ones is because these are already like denominators, and they're the only place where my variable is. Now you don't have to do this. You could actually, the second way would be to do what? Just the way that we did last time. I'm sorry. Say again.
What by 5?
Yeah. What's he need?
5.
A 5, and he needs 5, and he needs the t. So now they all have 5t. So now if I multiply by 5t, they all cancel, right? If I multiply by 5t, they all cancel. Is that idea, does everybody get that idea? Speak up now if you don't, because if you don't, at least 8 other people don't also. You could be their hero.
Wait, you multiplied. You multiplied.
So let me do this really.
I literally zoned out at that moment for some reason.
All right, you're lucky I'm going to do this. Here we go. So you could, you could go ahead and multiply by 5t. I kind of like doing it this way. It's a little bit easier when the bottoms get more disgusting. Give everybody what they're missing in terms of everybody else, right? We're used to that idea already. So give him a 5 because he's got a 5. Give him a 5 because he's got a 5. Give him a t because he's got a t.
Okay.
You guys with me?
Yeah.
And now what you do, let me go ahead and write what we got here so far. I'm going to show you more steps than you really have to. Now the beautiful thing about this is it's an equation, and an equation I can multiply. So in an equation I could try to get rid of anything I don't like. I don't like fractions. Well, in an equation you can kill them. If it's not an equation, too damn bad. Right? You've got to live with it. But how do I kill this part I don't like? They're fractions because it's divided by 5t, so I'm just going to multiply everything by 5t. It'll undo it. And the reason I'm allowed to do it is because it's an equation. I know I already said that, but I have to say it more times. So I multiply by 5t. All the bottoms cancel. What's left? You guys see that? And that's almost too easy to believe, right? How do you solve for t? Yeah, subtract 20, sure. Negative 5 equals negative t, so t equals 5. Is 5 okay? Totally, right? The only value that would not be okay is 0, because that would make the bottom 0. All right. And again, if we want to check it, 4/5 minus 1/5 is 3/5. So t equals 5 works. How we doing? The other way to do this problem, and it's going to lead into a method that a lot of us know, but we use way too often, because you're not allowed to use it as often as you try to use it. If I do, like Trenton said, subtract 4 over t, because aren't these like terms? What's 3 over t minus 4 over t? Negative 1 over t equals negative 1 over 5. Does anybody know what you're allowed to do here? Yeah, now the reason you're allowed, now stay with me. I'm going to show you the reason you're allowed to do it, and then I'm going to back up and actually do it straight, because the reason you're allowed to do it makes it look like there's more work. It's a shortcut. So what we actually do is we do the same thing we did over there. This guy needs a 5, and this guy needs a t. So if I multiply by 5t, I get negative 5 equals negative t. But what's it look like happened? It looks like the 5 came up there, and it looks like the t came up there. So really, what you do when you get to this step, you bring that there, and you bring that there. So you get negative 5 equals negative t. That's the shortcut. That's why the shortcut works. And then, of course, you get t equals 5, like we got over there. How we doing? Does that sound familiar?
Why can't you just tell that t equals 5 because the bottoms, like you already have the negative 1 on top, so t has to equal 5.
Oh yeah, good. So right here you can see t has to be 5. That kicks ass. That'd be awesome if you could see that. It's beautiful. Now, not every problem's going to be like that.
Yeah.
But in this problem, totally. You could just go, t's got to be 5. That's the only way that could be that. I love it. All right. So that one was kind of nice. It was relatively simple. That's why I had another way to do it. Let's look at one that's strictly cross multiplication here. Become a 3.
What number is that?
20. Still in census. So do you see the only time you're allowed to cross multiply is when you have one fraction equals one fraction. Because that's where we were here. And that's where the shortcut works. You guys with me? So people try to cross multiply in the weirdest times. The minute I teach cross multiplication, I say 3/7 times 5/4. And I get people telling me the answer is 12 over 35. No, what? How do you multiply, friend? You multiply. Right? So cross multiplication only has a very specific place you're allowed to use it directly. That's when you have fraction equals fraction, right? Now you can be creative and you can use the idea of cross multiplication in other places, but you have to be really comfortable with how everything else works. This is the only place you're allowed to just directly use it. So how would the next step look? I love it. 3a minus 12 equals. And notice how I still have an equation. Right? I can't have my equation suddenly disappear. I always get somebody tell me that they just say that and they circle it. Like, holy shit, no. You bring that up and you bring that up so that there's still an equation there. Right? Yes?
Can you just do the second step for that one, or no? Which is find the...
Oh, sure, yeah. You mean like give this guy a 3 and give that guy a...
Yeah,
yeah, totally. This is a shortcut of that. So that will still work, totally. Yeah.
Okay.
I like it. And then this is easy, right?
Yes.
Yes. Okay?
Minus 9
Good.
plus 12.
At 12, I get 2a equals 18, so a is 9. Is that okay? The only one that would, what would be the value or values that would be not okay? Just -6, right? Not 4. 4 is fine because it's on top. It's the bottom that would make it undefined.
That's kind of a trick when the quiz when they asked that. I was doing like factoring the top part. I'm like, wait a minute, no, it's just the bottom.
Yeah, the bottom, the top doesn't matter. I can divide 0 by any damn thing I want to. I just can't divide by 0. So it's just the bottom I got to worry about. Now, I don't know if you guys noticed, but my question on part 3 was actually part of the question on number 4. Too. It was kind of nice. I was actually trying to help you, so you don't have to factor it twice or something. If you didn't notice that, you're fine. Just got to factor it once.
Can you cross multiply when it's like 3 separate fractions? Or no?
No, because then, all right, let's kind of step into, yeah, okay. This is 5. So let me ask you this. I mean, If you brought the 6, where would it go? There's like 2 ups. And then what are you going to bring from here? 15 or 5 or 3 or 8 or something weird?
No, I was asking for the 2 that are attached kind of to the equal sign.
Oh, no. Be careful.
Yeah.
This is attached to equals in this. I mean, this isn't like hovering and these two can do stuff to each other, right? You can't just ignore part of your equation. He has to get affected by whatever it is we're doing. So how the hell would you do this? Jabba.
Multiply with what doesn't have, right?
Yeah, exactly. You can do it that way, totally. Yeah, so what's he missing? What would the LCD be?
30.
Yeah, you look at the biggest ones, it's got to be 30, right? So this guy needs 6, this guy needs 10, 5. So if you multiply by 30, all the bottoms go away. You guys see that? So I get, what do I get? 18 minus 20. That kicks ass, right?
Negative 2 over 5 equals X.
Good. Divide by 5, so x is negative 2/5. Kick ass. So you can't cross multiply, but it's fine, because it's not that hard not to. It's okay to do it the other way.
Now you said with that one, going back to what you said, you can't, I'm trying to word it right. Yeah, cross multiply, because that one has another term on there, right?
Exactly.
So only if that were to be.
If that wasn't there,
Yeah,
we
there
could
you
have
go.
all day long done
Okay.
this. But since that's there, it's like 6 goes where? There's too many things over there. It only works fraction equals fraction. Yes, ma'am.
So if you were to make the bottoms the same, multiply the 3/5 by 3 and the 2/3 by 5, and then do the math.
Oh, yeah, sure.
Could you then cross
You could combine these, and then you have 1 fraction equals 1 fraction, right? So, real quick, we'll do that, and then because I want to show you it will work. So you can take a look here. So we got 3/5 minus 2/3 equals x over 6. So you say, screw you for a second. These guys, the LCD would be 15. So that'll be 9/15, right? Minus 10/15. 9 minus 10. And then you can cross multiply. In fact, notice this. In this case, do you guys see why I wouldn't even cross multiply? If I multiply the 6 up, why would I take the 15 up? Because I would just divide it back down again. If I take the 6 up, x is by itself. If you don't see that, it's okay. Bring the 15 up, and then you're going to divide by 15 on the next step. Do you guys see what I'm saying, though? So then you'll get negative 6/15. Is that what we got over here? Not yet. Well, it is, but we just, what do you do this? Reduce it. Divide by 3, you get negative 2/5, which is what we got over there. Yes, sir.
Because Matthew's good question, but I thought you had to do the same thing to both sides. If you're just messing with this.
No.
on one side.
I didn't do shit to this side. 3/5 minus 2, stay with me. 3/5 minus 2/3 is negative 1/15. So if you saw, if it's an x equals 2 plus 3, what's the next step? X is 5. You wouldn't say, wait, you did something. No, I'm not trying to, no, I want to make this point. If you do something that's not there to one side, like I divide one side by 2 or I multiply one side by 7, then you better do the same thing to the other side. I didn't do anything to that side. Everything I used here was already there. I didn't multiply the side by 3. I multiplied top and bottom of that fraction by 3, which overall didn't do anything, right? I don't want you to think I'm angry. I'm just trying to make a point. Don't you doing that? All right. Cool. I like it. It's a good question because a lot of people are confused. It only means if I do something that's not there. If I introduce something new, I got to introduce that to the other side also, or else it's not fair, right? Okay. Cool. Okay. And just to do the ugliest looking problem in this section is what we actually kind of concentrated on last time. And here, let's do this one. This looks really nice. 39. This might be a homework problem, so sit up, pay attention. I have no memory today. Still section 7.6. So, people, the mistake people make on this problem, let me see, I'm not even going to tell you. You guys tell me what to do.
Factor that t squared minus nine.
Good, so factor that, how does that factor?
T multiplied by 3 minus plus 3.
Okay, yes. Keep going. What do I do next?
Get a common
Do again?
denominator.
Multiply by t plus 3 on the left.
Good, so he needs a t plus 3.
And then, so then that would be 5t minus 15 minus 30 on the top. And you can just combine like terms.
Equals
And you
what?
keep- And you keep the bottom.
Oh,
Sorry,
oh,
never mind,
sure.
it's equal one.
You
Okay.
can do that, yeah, that'll work. The big thing the mistake people make is they'll go to this step here. What mistake have I made?
You need to go over it.
Yeah, the one didn't happen. I took something away from the side that was there, so I did change that side. The other side has to change also. So really what you can do right now is two different things. I think the most direct thing is, once you get all the fractions the same, then you multiply by the bottom, right? But if I multiply this side by that, I better multiply that side by this. And he's got no bottom to cancel that shit out, so he just picks up everything, right? So that cancels out there. That cancels out there. Oh shit. So what do I have here?
5t plus 15.
5t plus 15 minus 30 equals,
T squared.
right? Because that was the t squared minus 9 there that we factor, right? Now how the hell do I keep going? How do you continue?
Well, combine terms of that, so it'll be 5t plus 15.
All right, good. Good idea. 5t minus 15.
And then factor that back out, and then factor that back out, right? So that'll be, no. Put it all on one side, make it equal to 0.
Beautiful. So what tells you to do that?
It wasn't 0.
You're like, I told you to do that. Nothing told me. But what tells me, if that t squared wasn't there, I could actually just get t by itself and divide and get and be done. Because there's a higher power of t, right? Which makes it sound all religious and t. The t's God is here. Since there's a higher power, it's the second degree, that tells me get it equal to 0 so I can factor. Right? Because I can't get my t stuff together, they're not like terms. So if I subtract 5t, add 15, I'll get 0 equals t squared minus 5t
Plus 6.
plus 6. Cool. And this is actually a factoring form that some of you guys have in your quiz.
T plus.
So this says they have to be the same sign, and this says they have to be add to be negative, so they both have to be negative. So what multiplies to be 6 and adds to be negative 5? Negative 3, negative 2. So you get t equals,
Positive 3.
good, positive 3,
Positive 2.
positive 2. And please, real quick, while I'm thinking about it, just because somebody else understands the problem, they say it doesn't mean that you're supposed to understand. There's something I'm doing. Everybody see where the 3 came from and the 2 came from, right?
Yeah.
The step I'm skipping is
You add
t minus 3 equals 0, or t minus 2 equals 0. And of course, we'll add 3 and add 2, so that's why they're positive now, right? But the quicker way is just what makes that 0? 3. What makes that 0? 2. Yeah. Now, are those answers okay? Every single time I've tried to make a point of this, at the very end, you always have to check. If you have a fractional beginning point, you got to check your answers and make sure they don't freak it out. Did one of those answers freak it out? Totally. Which one? 3. 3 would make that 0 on the bottom, right? So you got to just throw 3 out. Too bad, 3. Again, it's not math's fault. You're like, everything's math's fault. Yeah.
Can you explain again the beginning? I'm sorry. Where you got the 1, 2, 2.
Oh yeah, so when we got these to be the same, the next thing I do is multiply both sides by it, right? If I multiply both sides by the bottom, it'll cancel.
Yeah, but what about the limit? That's where I'm confused.
Well, I have to multiply both sides. So if I multiply this side by t minus 3t plus 3, I better multiply this side by t minus 3t plus 3.
Gotcha.
Now here's another way to look at this, real quick. All the work would have been the same, but look how I can look at this. From the very beginning, I put anything that doesn't have a bottom, I put it over 1. Now, if I want to make everybody have the same denominator, what's this guy need? He needs everything. You guys see that? What's he got? He's got a 1. What do these guys have? T minus 3. Oh, shit. I better give him a T minus 3 and a T plus 3. So when I multiply by that on both sides, it cancels, but this is still there, right? It had to be put there. One of those two methods has to make sense. You can't have a whole number at the beginning and it stays a whole number on the next step, because you have done something to both sides, but you have to. So it's got to change somehow, right? That's the idea. But it's so simple to make this mistake, because you see a whole number, you're like, why would I change it? It's not a fraction. It's not a choice. If you do something to one side, you got to do it to the other side too.
So that one's kind of simple. That the whole thing, whatever, was kind of on the quiz too, wasn't it? So if we basically did it like, whatever number camps out, make it freak out. If we did that final.
Oh, well, there was a question more directly about what's going to make this undefined. Yeah.
Oh, okay.
So you just have to factor it and see what would make it 0. Yep. Cool.
So that's, it's kind of like going backwards a little bit, because now you're just, well, not really, but what I'm trying to say is that one, like you said, is freaked it out. So that one, that denominator 0, that's not a solution.
Good.
So you just try.
But before we get this, we had to do it by itself to see why there are values that we couldn't use. So I know I can't use 3 or negative 3, so if they show up here, I got to throw them out. Yeah,
And
cool.
whatever you're left with is your.
Must be the answer. Yeah. Okay. So you could have 2 answers, 1 answer. You could have no answers if both of them freak it out. If there would have been a T minus 2 up here, I would have had to throw that one out too. All right. That's 7-6. I mean, we've looked at every type of problem twice in 7-6. So you just got to get into it and try it out. And while I'm thinking about it, I haven't gotten a lot of homework in any form, really. I've gotten some from a few people. Some people on WebAssign. You're on WebAssign, but there's nothing done. So I don't know what that means. Yeah. I mean, not WebAssign, but my math lab. I keep forgetting.
I'm new to my math lab, so what else do we need to do? I mean, besides a bunch of green check marks.
Yeah, you're good then. You could see your score, right?
Yeah,
it tells you
really
your score.
see it, though.
Totally, of course I can. Dude, it's my class. I can see every damn attempt you made.
Are you going to tell us that it's messed up or anything's messed up? Or?
Yeah, normally after the second test, or maybe even after this first test, we'll see if I got time. I give out a summary sheet of grades, and on there I put what homework I'm missing. But whatever you can see in my math lab, I see the same thing, because we're both looking at the same database, really. So if it says your grade currently is this, and you've done these things, I can see the exact same thing.
And then the last question, sorry.
That's right.
Last question I have is the wrong answers that I've submitted. Do you want us to do those again, or what's going on there?
No, so on the online homework, I give you 3 attempts.
Yeah, it gets tricky to change it up even if you do it.
Totally. And the textbook you get 2 tries. So you actually get 1 more try online. So, and what I do is in the textbook, I let people miss some, and I still give them a full credit. So online, it's normally about like 80% or so. If you got 80 or higher, you get full credit for it. You get 100. But I kind of look at each problem just to make sure you didn't miss any really important concepts. You kind of with me. So on the pencil paper homework, if some of you guys have gotten it back, I say okay, even though some of them are wrong. Or I say correct because either you missed way too many of them or you missed some really key concepts. So I need you to go back and look at them again. You with me? Yeah.
I'm okay to turn the written homework in all at the end, right? Like all up in test day.
You can. I'd rather you didn't.
Okay, all right. I
But
won't do that anymore.
you totally could. It's so much better not to. Whatever you give me by today, you're going to get back by Tuesday so you can study for the test. Whatever you give me on Tuesday or Thursday of next week, you're going to get back someday. Before the final, whenever I get to it. I'm actually getting a TA this semester for the first time, so maybe I'm going to have her do that homework that I normally don't have much time to get to. So at least it's looked at, yeah.
Do you have like days when you collect it, or no? Does it say it on
On the syllabus, totally. Totally spells that out on the syllabus. So it's only late if you give it to me after the test, but you really should turn it in like a week after I finish lecturing on something.
No, I mean, like, you know how you said it's good to turn it in before? Just checking for that too, right?
Say it again.
You can turn it in whenever you want.
Alright,
I couldn't hear you, dude. I can't answer your question unless I hear it. So, yeah, you can totally turn in early. Early's great. Late sucks. Early's awesome. Not a damn thing wrong. If you give it to me, I'll check it off the computer, look at it, give it back to you.
Thank you.
Sure. All right. I think you guys have gotten together. You're trying to not let me get into 7-7. But it's too bad. We are. We're just now going to leave later. So 7-7, I don't want to let you out of here before student 7-7 because you all are waiting for the word problems associated with it. So here they are. So these are word problems that are going to end up with variables on the bottom. And one of the classic word problems is actually called work problems. So something like this. These set up really nicely. If I can mow a lawn in 5 hours, it's a big ass lawn, right? It's giant. And my friend Bob can mow the lawn in 4 hours. Show off. Right? You can pay by the hour though, so hey, be smart. If we work together, how long would it take us to mow the lawn? Right? So obviously the answer should be how related to 5 and 4. If we work together, it should take less time than 4 hours, right? Because Bob alone is 4. If I'm helping him, it should take less time. Does that make sense? So here's how this gets set up. This is really almost too nice to believe. One lawn can be mown in 5 hours by me. One lawn can be mown in 4 hours by Bob. If we work together, we can mow one lawn in I don't know how many hours. And then that looks like section 7.6, right? So word problems are going to be, you got to set up your equation, and then they're going to start to look like the stuff we were doing here. And then you just attack it like we did here. So how would you...
7-7?
Yeah, this is 7-7.
Yeah, but it should look like 7-6.
Yes, yeah, your equations you're working with should look like the ones that in 7.6. So how would you solve this?
Give the bottom way.
Yeah, a few different ways. You could put these together and cross multiply, or you could just attack it directly. What's the LCD going to be? 20t, good. So he needs...
5-4T.
He needs a 4 and a t. He needs 5t, and he needs 20. So now I can multiply. So now let me do this out. I get 4t over 20t plus 5t over 20t. Thirsty. Equals 20 over 20t. And then what can I do with that 20t that's making all these fractions? Multiply everything by 20t. And I hope everybody gets that. It's just me being lazy, right? But it's everywhere. You multiply by 20t, this side and this side, so it distributes to both. So it cancels everywhere, right? Yes, sir?
Why is it in a fraction form? Why is it?
How do you mean?
Why is it 1 over 5 plus 1 over 4?
All right, so the idea behind this is, the book explains it one way, but I like this way better. So I can do 1/5 of the lawn, Bob can do 1/4 of the lawn, together we can do 1 over t of the lawn. So if I can solve for t, I can see how much time that is for us together. The book explains it, and the book explains it in an interesting way. It says, this is the percentage of the time that I take to mow the lawn, plus the percentage of the time he takes to mow the lawn would equal 1 lawn mowed. But I mean, they both end up in the same place. They both kind of end up with the t's. If I multiply the t up, there they are, right? That one just kind of gets there a little bit clearer. I like this because it's just 1 in this many plus 1 in that many is 1 in, I don't know, together. So what am I left with here?
9T.
Yeah, 9t equals 20. So t equals 20 over 9, which is 2.2222. Right? 2.2222 hours, roughly. Not too bad. Cool. All right, how's that one? That's one
You can leave
example.
it like that, right? Like in a test, if we were to leave it 20 overnight, you wouldn't mark it wrong.
Yeah, at least put hours, right?
Okay.
But yeah, it's all right. Yeah. But it'd just be weird to say that to somebody. How long does it take you to mow lawn? 20 divided by 9 hours. You know, it'd be like, who are you? How far from school do you live? Square root of 11 miles. I'm not talking to you. So here's another kind of problem in this is distance, rate, time. And what's the equation that relates distance, rate, and time?
S equals D or something like that. D equals
That's right.
rate of rate times.
Dirt. D-E-R-T. D equals R-T. And we do this all the time. You're going 80 miles an hour for 4 hours. 80 times 4 is 320. You can get 320 miles, right? If you're going to LA, you're actually going slow. I learned that quickly after I moved here. I'm like, holy shit, all right. I thought I was going to pretty decent speed. So the kind of problem we're going to see dealing with this, let's do one right out of here. All right, so Olivia, on the road bike, doesn't matter the person's name, but her name is Olivia. On the road bike, she travels 15 kilometers an hour faster than Jason. All right, so whatever Jason does, she does 15 kilometers an hour faster, right? On his mountain bike. We'll see if that's important. That makes sense. Mountain bikes are not really built for speed. Olivia, in the time it takes Olivia to travel 80 kilometers. So Olivia goes 80 kilometers. In the same time, it takes Jason to go 50, I think. Yeah. So, I mean, this sounds like your classic word problem. It sounds like, you know, when you die, you can't enter heaven until you answer this question. Just send me to hell, man. I don't know if you guys have ever seen that Far Side. One really nice way to set these kind of problems up, you don't have to do this if you have a different way to do it, but it's really kind of nice. There's almost always two parts to these problems. Distance equals rate times time. You got Olivia and you got Jason, right? OJ. Oh, I still remember I watched that. Some of you guys might, when did that happen? Were you all born at that point? Some of you guys might not have been born. Holy shit. You get to read about it, and oh, it's horrible. You don't know when OJ was a good person. You don't know. You weren't alive then. So I just start filling in this. The nice thing about this chart is it organizes my stuff. What do I know for sure? What do I know? No question. What do I know? No question. Olivia went 80 kilometers, so that's distance. And at the same time, Jason went 50. Now I get into the stuff I don't know for sure, but I at least know the math behind it, right? So what is it that I don't know? I don't know how fast they're going, but I do know Olivia is faster, right? Olivia is 15 kilometers faster than Jason, so who's going to be X? Jason. So if Jason's X, Olivia is... You guys see that? The minute you have only two boxes left open, we use the equation to get them. So what is that I don't know? I don't know their time, right? If distance equals rate times time, how do I solve for time? What do I do to get t by itself? Divide by rate. So the time is distance divided by rate. So this time should be distance divided by rate. So what goes here? No, I'm trying to get time is distance divided by rate. And what's this one? And what's it say about the times? So whatever time this is has to be equal to that time. And see, this is what I told you guys. They're going to end up looking like equations from section 7.6, right? And what method could you use to solve this? Cross multiply. Cool. That's where we'll stop, actually. So. That's 7.7. So Tuesday I'll have the answer key for that practice test. The quiz is great. Oh, cool. All right. Oh, put your name on it. What's up? Oh, yeah. What's up? Oh, good. Thank you.
Yeah, Chris corrections on the back.
Sweet.
So for the real method.